Okay, and we say off and on, you know, there's no in between. It's not kind of on, it's not kind of off. Usually things are off or they're on. Okay? So when we think about opposites, it's going to be very important for us today when we familiarize ourselves with what are called equations. Mathematically speaking, if I were to ask you, what is the opposite of multiplication? Sometimes they use the word inverse. Yes, division. Okay. If I were to ask you what the opposite of addition was, mathematically speaking, you would say, Larissa, subtraction. And notice these go both ways. The opposite of subtraction is going to be addition. The opposite of division is going to be multiplication. Is the opposite of multiplication ever addition? No. Okay? Those don't cross. They only apply to their counterpart, their opposite. Okay? Any questions about what we're doing so far? Okay, kind of a little part English, part math, rolled into one. The other thing I want to talk about is this. You know it as an equal sign, but what does it really mean? What does it really mean? Frank, same as. I like to write that down. Same as. What else does it mean? What else does it mean? Alexis. You were about to say something the same as. Same as. Nah, not the sum. But good try, Carlos. The answer. He also said. I'm going to tell you something, though. The problem is, this is not necessarily what the equal sign tells us. And this is kind of the problem when understanding what equations are, what we're finding out, is that you've been conditioned so long, and you've been conditioned by so many problems when you were given all those worksheets in probably second, third, fourth grade, and you had to do 100 problems, and you had to sit there, and you had, 2 plus 3 equals. And I know, right, 6. And that's not? No. 2 plus 3 is 6. Okay? But what you knew was, I'm going to get a problem. And that problem is going to follow this familiar format. I'm going to have what I have to do on one side, and then I'm going to process it in my brain, and it's going to spit out an answer on this side, correct? Right. And that there was a certain direction that this equal sign meant. It always meant my answer is going to be on that side. So much so that when we see something like this, we say, I don't know how to do this. Because to me, that looks what? Looks backwards. Here's a newsflash. There is no such thing as forward or backwards when it comes to equal signs. This is exactly the same as the other one that we have. It's exactly the same as this. Why? Why? You're right. I did turn it around, Desi. Answer. Let's go away from this term, the answer. And let's move closer to the term solution. Doesn't mean if you have a solution or if you solve something. Yeah. To take the what? If you solve a problem, what did you do? If you solved a problem, what is it that you did? Usually if there's a problem, there's something wrong, right? To solve it, you made it right. All is right again. You solved it. You solved the mystery of the pea bandit. You found out who it was, right? You found out who it was. So, when we think about equations now, that's how we think of them. This equal sign, it doesn't move in a certain direction. In fact, the equal sign, it's almost like a scale. Do you ever see those old scales where you've got, you know, two sides and you've got to even them out so that it's exactly the same? Or like you even have seesaws or teeter-totters anymore at parks. And if you put two people on opposite ends of that teeter-totter, what would happen to it eventually? Could you make them balance? Would it mean the same? Yes, because their weights or their mass was equal, it all leveled out, okay? So when we think of this equal sign, I'm going to have values on either sides. This is a side, this is a side. And no, this side on the right is not designated as where I put my answer. It just means this. Is the value on this side of the equal sign exactly the same or equal to the value here? Yes. 2 and 3 is what? 5. It is 5. This is also 5. It's just a different way of writing 5, isn't it? 2 plus 3 is just a different way of writing it. But its overall value is still 5, and the other one is still 5. Okay? Now, in equations, you turn to page 306. You're going to take notes, you're going to need paper. Let's take a minute to examine the first equation that's up on the board. What makes that, first of all, what makes that an equation? What's so special about that one up there that would make it an equation? Desi? It does have an operation sign. I don't know if it necessarily makes it an equation. If that's what makes it, that's part of making it an equation. Let's say that. Carlos. That's ditto. Echo. Operation sign, plus is an operation. Part of it, yes. Why would I ask you this question? Why? 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 Larissa? And why, what do we call that when we have a letter that takes the place of a value? Yes. Variable. Okay. Now, what is it that I'm trying to find out here? And no, it's not the what answer. I have the answer. If it were that easy, I would circle the 14 and move on to the next one. But that wouldn't make any sense. It's not complete. So I need to find out what does y equal to make this side of the equal sign equal this side. I need to make this side equal 14 because this side equals 14. Right? How do I do that? Well, let's think opposites. Remember we talked about the opposites for operations. We said when I have addition, the opposite's subtraction. Multiply, the opposite's division. What is currently happening in this problem, in this equation, is addition. And if I examine this side, there's nothing else I can do with this side. This side is this side. 14 is 14. There's nothing else I can do with it. There's no plus sign. There's no subtraction sign. It's just 14. But here, I need to find out, we told me already, what y equals. Now, equations are built for the middle school. They're built for 6th grade. Do you know why? Because they're fair. You guys are all so worried about things being fair. Oh, we had basketball practice and we had these teams and they just weren't fair. Wah, 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 cry me a river. Equations are fair. Because what gets done to one side, finish it, gets done to the other. Every time. So nobody gets special treatment. I know how much you hate that. What's happening to y right now? We are adding 5. The opposite of adding 5 will be to what? Subtract how many? 5. So, if I were to subtract 5 from this side, what would I have to do to this side? I would also have to subtract 5. Question? Okay. Now watch what that did. What did we say we had to find? We had to find out. We had to find out what y equals. So if I can solve part of this over here, what is a 5 minus a 5 equal to? 0. 5 minus 5 is 0. So y plus 0 is the same as saying just y. Now do I have the y equals I was looking for? What is then 14 minus 5? 9. How do I know for sure that 9 is my what? Solution? How do I know if 9 is my solution? Casper. If I'm going to say y is equal to 9, then you know what? I'm going to find out. I'll put 9 there. if that equals 9, is 9 plus 5 the same thing as 14? Then we have a solution. I will think opposite. Whatever is currently happening on the same side as my variable, I'm going to do the opposite, and I'm going to do it to both sides. That will isolate the variable, give me the y equals I'm looking for, and also provide me with my solution. Okay? X plus 4 equals 19. Someone walk me through the process. Explain to me what has to be done. Go ahead, Desi. I have to find out what x equals, right? Okay. How am I going to do that? What's happening on the same side? Where's the action? What's the action on the same side of x? Yes? No. What is the action? What's happening? What's happening on the same side as x? So I have x and I got all this action going on here. What's currently happening right here? Adding how many? 4. So I need to focus on the opposite of adding 4, which is going to be subtracting 4. So if I subtract 4 from 4, I'm left with just x. Subtract 4 from 19, and we get 15. Is 15 my solution? Only one way to find out. If I say x is 15, 15 plus 4, is it 19? Therefore, I have my solution. Okay? I'm just working on the opposite. Okay? I'll give you 2 to try on your own. Now, I want to see this. I want to see some evidence that you worked through and thought it through. Because if you're telling me, I already knew that x was equal to 15, I could figure that out in my head. Great, good for you. But once you get to a point where you can't figure it out in your head anymore, you have to have a plan. You have to have some kind of a method that you have to use to find the solution. So you practice it, and you practice it, and you practice it until it just becomes second nature. So let's do this. N plus 6 equals 6. And let's say z minus 7 is equal to -1. Variable n. What's happening to n right now? We're adding 6, right? The opposite of adding 6 is what? Subtracting what? 12, 13? Right. So take away 6, I'm left with n. Take away 6, I'm left with 0. Is 0 plus 6 equal to 6? Very good. 0 is our solution. Here, z is our variable. What's currently happening to z? We're subtracting 7 from it, so the opposite is going to be adding 7 to both sides. Add 7 here. What is a -7 plus 7 equal to? 0, right? Add 7 to a -1. Start at -1, move to the right 7 places, +6. Is 6 minus 7 equal to -1? Therefore, we have a solution. Do not get fooled on the trying to solve the problems with your eyes. Okay, I see a 6, I see another 6, this must equal 12. Well, not when you plug it in. 12 plus 6 is not equal to 6. Doesn't make any sense. That's why there's a process. That's why there's questions you ask yourself, especially when you get something that you used to panic about. you get something like this. Wait a second. That variable n, we're supposed to start off with that one. We can't put that one where it is. It looks out of place. Not really. Remember before when I told you that when you look at things as being plus or minus, we can also look at that as being positive or negative? Same thing. Is my n positive? We're good, right? What kind of 4 is this? Positive. I need to get rid of that positive 4 so I can get n all by itself on this side. How would I get rid of a positive 4, Edsel? Or just subtract 4 from, we'll subtract it from both sides when we do that. So if I have 4, I take 4 away, what's left? Just my n, right? Take 4 away, what's left? Plug it in. 4 plus 6 is a 10. Therefore, that's my solution. Here's another one. Is there anything wrong with how this is written? No. Good answer. Is there anything different about the way this one is written than what you're normally used to? Sure. Is that going to throw you off? Is that going to change the process? No. So what's the variable? N. What's happening on the same side as n? We're subtracting 6. The opposite of subtracting 6? Adding 6. So when I add 6 to a negative 6, I get 0. N plus 0 is just like saying n. So I'm going to add 6 to my already 20. 26 is equal to n if I plug it in. 26 minus 6, is it the same as 20? My solution. Okay. Now, once you think you got the hang of things, then your book comes along and throws you a couple of curveballs and says, all right, you think you know what's going on? Let's find out for sure. Now, instead of having just one operation, p plus something or p minus something, now I've got 2 operations in there. We need to find out exactly what we are either going to add or subtract from both sides, right? That's the process. That's what we've been doing all along. As you look at just this whole side, here, is there anything you can do with it? Do you see any adding, subtracting, anything, or is it just a plain old 23? Is there anything on this side that you can do because you do know what the numbers are? Edsel. I can. Very good. I can take the positive 5 and subtract 4. 5 minus 4 leaves me with what? What kind of a 1? So here I'm going to rewrite this p, and I'm going to put that positive 1 down. Now it looks like one that we've been doing on the previous slides. Now do I know what the opposite is that I have to do to both sides? What is it? What's the opposite? Subtract how many? 1. P is equal to 22. How do I know for sure again that P is my solution? Plug it in. 22 plus 5 is 27. 27 minus 4, 23. If I can simplify to find out exactly what's happening, then I'll know to do the opposite. Okay? Why did I have to subtract? So you asked me? Subtract where? This one? Because a positive 5 minus 4 is what? 5 minus 4. 1. It's positive 1. So I went P plus 1, positive 1. The opposite of adding 1, subtract 1 from both sides. Try that one. It's going to be up to you to change it. Now, very similar to the last one that we had, we've got multiple operations on this side. Nothing's going to happen right away to this 38 until I decide what to do to it. Any advice? Anyone find out what they were supposed to do? Yes? Okay, kind of. You're halfway there. But I need to find out here what I want to do. Zay? So if you want to focus just on the plus 6, how am I going to get rid of a plus 6? What's the opposite? Subtract 6. I could take it piece by piece if I want. So if I want to subtract 6, now what's left? Y minus 12 is equal to, what's 38 minus 6? 32. Am I done? No. Now I got to focus on the negative 12, or minus 12. The opposite? Add 12. Y equals 44. Plug it in. 44 plus 6 is 50. 50 minus 12 is 38. Now, had you gone a different route and taken a look at the entirety of it, Liam, what happens when you have a positive 6 and you subtract 12? What do you get? So here is what this side is really saying. And the opposite, Liam, would be what? We're going to add 6 to both sides, right? Do we still get 44? Yep. So either way works as long as you're consistent with the opposites and your operations are the same as you would if you lumped it all together or if you didn't. I think we've reached our attention span limit for today. So essentially 1 through 10 except for number 2. 1 through 10 except for number 2.